the lush green IIT Madras campus, with a student population of over 7,700, miracles of tiny pieces of matter attract several people. Our laboratories principally focus on nanoscale materials. This lab of Professor T. Pradeep focuses on nanoscale materials. Here, researchers create nanoscale particles, particles composed of a few tens of atoms to thousands of atoms using chemistry. The very small ones are smaller than a nanometer. Their unique properties and diverse applications are studied. Most of the time, the lab focuses on new science that can be used for water purification.
In this lab, we are exploring ice. To study ice, we have built this infrastructure. What we have made is a very high quality vacuum chamber, which is called ultra high vacuum. So we take here a single crystal, deposit molecules of ice over that, and then collide ions, mass selected, energy selected ions on these surfaces, and then study the scattered ions with another mass spectrometer. So this whole thing would be called a reactive ion scattering spectrometer, which is coupled with infrared spectrometer and a few other spectroscopic facilities. So as a whole, this is a very unique kind of instrument. This is the first instrument of its kind in the world.
Science at the nanoscale in IIT Madras is diverse, just as in any other institution. We have some of the finest facilities with which nanoscale materials can be visualized. Atomic scale packing in these objects can be seen. We explore these objects as they can be very useful in finding new phenomena. For example, in a new work, we showed that just 9 molecules of the explosive trinitrotoluene or TNT can be detected with one anisotropic mesofluor. In the absence of TNT, it is red, and in its presence, it is green. This means that we have a single particle sensor.
The unique thing about this whole laboratory is that we create matter, explore their properties, take those properties to applications, implement those products in the marketplace.
There are over 50 faculty members in IIT Madras exploring diverse aspects of nanoscience and nanotechnology. In the Nanofunctional Materials Laboratory, Professor Rama Prabhu is exploring new forms of carbon. One of the focus areas of his research is to make highly efficient hydrogen storage materials, as hydrogen is likely to be the future source of energy. Functional materials can be created atom by high-energy lasers. Professor Ramachandra Rao makes several such materials as they are useful for new photovoltaic devices and many other areas.
We have a large number of facilities in this center. A part of this center is also called the Nanofunctional Materials Technology Center, which was established in 2009 with the funding from DST and industry. We also work on the next generation solar cell materials, photovoltaics. These are based on selenides and sulfides, copper, indium, gallium diselenide, CIGS, and CZTS are the future materials for alternative solar cell materials. And if you prepare them in nano form, especially in nano ink form, you can spread this ink on substrates which are also flexible. You can think of making flexible photovoltaics.
The materials developed in our labs are used for several applications. Professor Sarit Kumar Das was one of the very first to observe large thermal conductivity enhancement in dilute nanoparticle suspensions called nanofluids. He, along with others, wrote the first monograph on this topic.
Nanofluids are new generations of dilute suspensions which can connect material science, electronics, and biology. At our lab, we are working on ablation of tumors using these fluids, as well as cooling of electronic devices using them, and we are getting fascinating results.
Several nanoscale devices are planned in a national facility being set up at IIT. The objectives of this multi-user facility are manifold. Obviously, we can't cover all. The subject is being explored in almost all departments across the campus. Professor B.S. Murthy is involved in the creation of nanostructured materials, mostly by top-down approaches for both structural and functional applications. Creep resistance and piezoelectric properties are enhanced in the materials created. Professor Murthy has demonstrated that nanostructures improve the recovery of metals from lean ores.
We at the Colloids and Interfaces Lab have been putting cohesive efforts centering around functional amplifiers towards building higher functionality structures, beginning from their design, molecular modeling, synthesis, electronic structure calculation, and fabrication aspects towards higher functionality structure building and pattern formation.
Professor Pratap Haridas creates carbon nanostructures by the arc discharge method and explores ways to enhance their electrical conductivity.
Our research group in IIT Madras have 3 projects regarding nanochemistry. One project deals with using renewable sources to generate and stabilize metal nanoparticles. In another project, we use dendritic nanostructures to generate and stabilize silver and gold nanoparticles. Our interest is to study the kinetics of formation and growth of metal nanoparticles. Third project is the water purification using dendritic nanostructures. We develop organic inorganic hybrid systems using dendrimers and then study the removal of toxic metal ions as well as textile dyes which are dissolved in water.
We are working on photocatalytic system for the treatment of contaminated water with emerging contaminants like pesticides, endocrine disrupting agents, etc. Usually the photocatalyst employed is TiO2. The common TiO2, whatever is commercially available, is getting excited only in UV radiation. But in rural areas, if you want to treat the water, UV radiation may be costly. So what we are trying to do is, we are modifying the TiO2 so that it can get excited in visible light or in sunlight, so that we can use this system for the treatment of contaminated water in rural areas.
Our faculty members have developed courses in several of the advanced areas of nanoscale science and technology. We have authored books in this discipline, and they have become accepted textbooks across the world. Our labs are indeed some of the very best, equipped with advanced facilities to investigate science of the small.
campus is just not a collection of instruments and facilities. There are plenty of opportunities to rejoice. Come, explore with us.